Welcome to the Scalable Computing Podcast, joining you from Stanford in the heart of Silicon Valley. In this podcast, we discuss everything about cloud computing, machine learning, and large-scale systems. This season, you'll be joined by world-renowned guests from both industry and academia who have engineered and built some of the largest scalable computing systems in the world. Your host is Dr. Lamia Youseff, a scalable computing leader, one of the early engineers at Google Cloud, and former Microsoft and Facebook technology leader. This podcast is sponsored by Jazz Computing, your tech advisor and partner in scalable and ML engineering. Sign up for updates and new episodes at jazzcomputing.com/podcast. And without further ado, let me welcome your host, Dr. Lamia Youseff.
Welcome, everyone, to the Scalable Computing Podcast. It's really a pleasure to have Peter Bailis with us today. Peter is one of the youngest computer science professors at Stanford in computer science, and he got his PG from UC Berkeley before becoming a postdoc at MIT and working on one of the most exciting areas, data-intensive systems. He's also the founder and CEO of Sisu. Sisu is one of the hottest and most exciting startups in the Bay Area and in the Silicon Valley. Welcome, Peter, to our podcast today.
Thanks so much for having me here. Really excited to be here.
Of course, we're very happy to have you today with us. Peter, tell us from the very beginning, what got you interested and excited about doing research in data-intensive systems?
Yeah, I actually got my start in computer architecture, looking at how do you keep chips cool, and then I got into multi-core computing. And one of the things I realized over time as I went deeper and deeper computer systems is that in database systems, you get to touch on so many of the fun parts of computing, like programming languages and scalable abstractions and scalable execution environments. And yet you get to build end-to-end systems. You're not just building just the processor, just building the OS, but in many cases, database systems are like a complete application development environment. And so I kind of got sucked into data-intensive computing by accident, and then kind of stuck with it because I realized I could work on just about any problem I wanted to, and that almost every interesting computing problem takes a lot of data. And then the database systems toolkit gives you the set of techniques like query optimization, physical data layout, and a bunch of tricks you can play over and over again in different domains. And as people think of new things to do with data, there's more problems to go solve.
Totally, very true. This is super exciting because also you found a really good gap in the industry on how it's being addressed. You recently founded a startup, Sisu. Tell us more about the journey. How did you find the gap? How did you identify it and verify that there is a gap in the industry?
Totally. So when I was starting up at Stanford and getting ready to move over to Palo Alto in 2015, I started thinking about how I want to spend the first 7 years of my academic career. They give you kind of that much time before they kick you out or decide whether you get to stay at Stanford. And what I started to realize is there's a lot of really large scale data, and there's a lot of cheap computing. And so our initial working question was, if data was free to store and compute was infinite, what would you build on top of all of this? And we found through that kind of extreme lens that, especially with technologies like Snowflake and Redshift and Spark, we were nearing that reality pretty quickly. And what was essentially missing was this gap between the data that people had been collecting and their ability to actually do stuff with it, where you'd have these amazing advances in like OLAP and MPP warehousing in the form of, again, cloud warehouses like Snowflake, but then you'd throw like 1995 era visualization interfaces on top of it. And very quickly in this regime of cheap storage and cheap compute, the people became the bottleneck. And spending time with people who had access to more data than was like on the internet when Google launched, but all that data has to do with their products and their service and their company. It was clear you need a different set of interfaces and abstractions to let them actually understand what's going on in their businesses and why, using all the data they've already got.
Absolutely, totally true. It's usually that, especially with the cloud, it's computational power is very cheap nowadays and very accessible, but it's usually, like people are the main bottleneck in the area.
Exactly. And then, it's a kind of fuzzy research problem to go say, well, how do I prioritize people's attention and all of their data? But we went and talked with a bunch of early users, and then ultimately people who funded our research, like, Facebook and Microsoft, and basically found this pattern of people have metrics defined on top of this data. They get assessed based on these things, like, their pay and their performance is assessed, but they have no clue why they're changing. And that was a problem we found was basically universal when you look beyond just FANG, because if you look at what's possible with the cloud today and data infrastructure, more people have access to this type of data than ever before. And it was, not just a systems problem in terms of scaling up computing, not just a UI problem in terms of defining like a better looking visualization tool, was kind of this combination of the two that got me really hooked.
I love it. I love it. Definitely makes a lot of sense. So you're solving the problem at Sisu. Tell us more. How are you solving it?
Yeah, so the way we approach this problem at Sisu is we take instead of a dashboard centric approach, take a metric centric approach. So customers like Samsung that uses to help understand who's buying, and upgrading their phones, they already have defined metrics like activation rate and conversion rate, and they already have mass amounts of data in the cloud about their customers and services. Mm-hmm. And importantly, unlike kind of Facebook and Google, where the data is the product and they're going to monetize user data, for the majority of our customers, they're never going to sell this data. They're just going to use this data to make their own products and services better. Mm-hmm. And so what we do is we sit on top of all that data they already have. We start from where they already are in terms of their data lifecycle and journey. We take the same metrics they've already defined for their business. And what we do is we watch those metrics as they change. And every change that occurs, we notify users, not just that it happened, but also why it happened. So for example, if conversion rate is up, today versus yesterday, what drove that change? Was it a uniform 1% increase in conversion rate? Or were there segments that were disproportionately affected? Is it something on a new campaign that was launched? Is it something on a given demographic? And basically the value prop for our customers is they can stay on top of every change of their business without having to manually put in the analysis time to go and slice and dice on their own. And when something does appear, let's say there's a new metric or there's some event that they want to go dig deeper into, we can literally go 30 to 100 times faster in terms of automating that slicing and dicing process for them, so they don't have to wonder why.
Absolutely. And I love that you mentioned the focus on why the data changed more than that the data changed, because oftentimes what I've seen in enterprises is that they wait till the data is significantly changed before it gets their attention, and then they have to go on a complete different journey of just like tracking down what's happening in the data and why change it, and then it's too late to kind of correct the situation later on.
Absolutely. I think there's this cultural shift that's happening, and the reason why people do this kind of reactive root cause analysis today is because they don't have the right tools. Right. Mm-hmm. So if it's going to take me literally days, sometimes weeks to understand why any individual change occurs, I'm only going to go and do it when things are really hitting the fan. Right. But if I can do that cheaply and easily and continuously, then I can actually afford to stay on top and be proactive with my data. And that's a complete shift in terms of behavior. And that's only possible now based on the data that's available in the cloud, and only possible with the right tools that bridge that gap. And I think that it's possible on a technical level because a company defines its metrics once a year, sometimes once a quarter. If you're changing them more than once a week, something's, you don't know what you're optimizing. Yes. But the data is always changing. So we can set those metrics once and then track every change as new data arrives. Then you basically amortize the cost of any setup or any data connection and so on over the course of literally what would be person years worth of analysis that you're saving by just hooking up the right tool. And that can enable this kind of cultural shift from oh crap, something happened, let me go dig in, to like, I can sleep well at night. I don't have to worry. I can make my decisions with confidence because I've systematically and comprehensively looked at this metric and know what's going on.
This is at the heart of every digital transformation, what you just described. And it's what's enabling every digital transformation that every company is now racing to get to and to be able to stay in the market and to stay relevant. So it's
absolutely. Well, it's so funny too, because the digital transformation, in many cases people say, okay, great, I got to migrate my on-prem data to the cloud, check that box. Now I'm going to democratize access to the data by buying a bunch of BI licenses. They check the box and get, 1,000, 10,000 dashboards. Okay. And that gets you to the point where suddenly, instead of getting like quarterly reports, you can get daily reports on what's going on, but it doesn't solve the problem of understanding, well, what do I do about it? Right. So I can track these metrics. You can see something's flat or it's down or it's up, but how do I respond? And it's just not feasible to scale people to keep up with the number of dashboards and metrics that are being tracked. I mean, even within the best funded organizations, like the FANG scale organizations that were early adopters of the technology behind Sisu, even in their number one, money-making products, say the ad the ad campaigns that they're making people click on more ads. Like the ad campaign managers who are responsible for the Nike account or the Adidas account, they don't get their own analyst, right? They're doing it all on their own. And that's where I think there's this opportunity not to replace that analyst, but to provide that kind of ability to augment human intuition with heavy lifting to do the repetitive, routine, boring parts of understanding, okay, did something change? Is it important? And how should I respond?
I love that. Shifting gears a little bit, building a startup, especially such a very powerful tool and such a powerful market opportunity, is no easy walk in the park. Tell me more. What helped you in the early days make this decision, and what was most helpful to you to take this journey and from becoming a professor to becoming the CEO of a very young and quickly growing startup?
Yeah, really early on when we were thinking about, thinking about the company, we knew there was kind of a there, and that we had seen this pretty interesting uptick in adoption among some really cutting edge companies. And the question was, how do you make this more successful and more accessible to more people than just the biggest tech companies who can afford to throw a bunch of PhDs on integrating this into their infrastructure, right? And I think what was missing for me in the academic context was the ability to work with people who were not only great technologists, but had other skill sets beyond just, solving hard technical problems. So for example, quickly realized that the ability to work with designers and product visionaries and people who can really optimize for scale and robustness, and then marketing and sales, right? Like, especially from an academic context, marketing and sales can seem like, no one likes to be sold anything, right? But the reality is, especially in a crowded market, like there's a lot of value in that storytelling that comes out of, okay, how do I position this? What is the benefit? Why would someone change their behavior? And my biggest impetus was actually one of my grad school advisors and kind of personal mentors, Ali at Databricks. He pointed out that as a professor, you get to work with some of the smartest people on the planet in the lab. And I've got some amazing students, way smarter than me. And you train them up on how to do research, and they get really good at it, and then they graduate after about 5 years. In contrast, right, in the company, you get to build a team of people where there's no fixed point where it's like, okay, great, you got to graduate with your PhD and here you go. They're better than you at their different disciplines, and you're bringing together people who might never otherwise work together. And then you're also in all the same boat. It's not who's first author, who's second author. It's like we're all building this thing, and we're growing this pie, and we're all in the ship rowing the same direction. And that's really, really, really rewarding. It's super hard because you start off with something that's not much of a ship at all. It's much more of kind of an idea and some early evidence, and you build it into something bigger. But for me, the most rewarding part about this, and also the most challenging part of this, has been kind of assembling that team to go, take over the world together.
Absolutely. What's your advice to young researchers and engineers who are just starting in the field, whether in academia or in industry?
Yeah, I think the bar for making useful products, especially in kind of analytics, and by products, I mean, it can be an open source project or a tool or a script or others, it's really never been lower. And that I think the 2000s and early 2010s, a lot of the state of data was Google's way ahead of everyone else. Let's just read what Google's doing, what they've published on, and we'll go build an open source version of that. And if you look at the problems that many companies face today, it's much smaller amounts of data. I mean, it's still astronomical by like the standards of 2001, 2002, but it's not internet scale, right? And there's a lot of nuanced problems around data collection, cleaning, integration, storage, visualization, taking action, where you have now more than ever a huge total addressable market of people that are on the bleeding edge, that are not just Google and Facebook and Microsoft. And if you can solve problems for them, even in the lab, right, there's a good opportunity for you to have this larger impact. One of my favorite tools, for example, in the space is there's a company called DBT, which is basically data build tool. And it's an open source project that started as a way to kind of version different types of data transforms that this company Fishtown had to do. And they originally started as a consulting company even. And this DBT tool has become this big initiative and community and effort. And again, I think the fun part for me is that it's almost like this Cambrian explosion of problems and associated solutions, where it's not just driven by big tech anymore, because everyone has these problems. So the concrete advice is, find some hard problems. Don't worry about making them too repeatable, and get people to use your stuff, and, stay hungry.
Love it. Stay hungry and find hard problems and go solve them. I love that. Well, that brings us to the lightning round. Are you ready to play?
Yeah, let's go.
Awesome. So the first question, most impressive startup or open source project you came across recently?
So I already mentioned DBT. I think they're really smart and very cool. I also like this company. They just raised a big round, Monte Carlo. They're basically doing monitoring and observability, not for data centers, but for data. And I think this idea of data observability and monitoring data downtime is a really great idea, pretty broadly applicable. And as you have more and more systems that are out of your control to pipe data into your warehouse that are ultimately making business decisions, you better make sure if your data is legit or not. And that's just a great idea, perfect timing in the market. So big fan of Monte Carlo.
Nice. Most surprising use case or application that you have seen at Sisu so far?
Best part of this company has been getting outside of tech and realizing how many people have this problem. So my favorite use case, just personally, was working with, I'll obfuscate some of the details, but looking at customer satisfaction data from a large fast food chain and realizing that a recent change in the sauce provided by a regional store manager had led to a disproportionate increase in customer dissatisfaction, and they needed to switch back their sauce for one of their flagship items because they were really driving down same-store sales with this crappy sauce they had switched to.
Yes, awesome. Interesting, very interesting. Most challenging or surprising aspect of building a startup that you didn't expect?
The most fun part about this, and is also the most challenging, which is the job's slightly different every month because things continue to grow. It's just learning at hyper speed. And looking back even 3 months, 6 months, it's just unbelievable how quickly things can change, how quickly you can grow. And it's the best growth environment I've ever been in.
Love that. The future of data-driven decision-making is?
Not an algorithm, but algorithms plus systems plus people.
Nice. And cloud providers are shooting themselves in the foot because specifically to data-driven decision-making systems.
I think they're shooting themselves in the foot because it's not an infrastructure problem. It's a product problem. You know, you can get the world's fastest, cheapest data warehouse in the world, but that's not going to close the gap with the people who actually make the decisions. There's this pretty big missing link. Obviously, we've got a strong thesis on what that link should look like, but someone's going to go solve it, and I don't see the cloud providers taking the big swings necessary.
That's super awesome. Thank you, Peter, so much for making the time to join us today and sharing with us very insightful conversation into data-driven decision-making systems and your research, as well as advice to young researchers. Thank you
for having me.
Joining us.
Yeah, really appreciate it.
Sign up for updates and new episodes at jazzcomputing.com/podcast.